very long.
Wait, so
So today we're going to be talking about 4.3, or sorry, 4.6, inverse trig function. So if you remember, inverse functions, you just switch the x and the y and then you solve for the new function, right? So with this, our regular functions are functions that we know of were like y equals sine x, right? We had something like that where the y value was our function value and the x was the angle. So if I want to find the inverse function, if I switch the x and the y where they are, I have to solve for the y value. Well, if you remember from, what was that, 4.1, I believe, when we were trying to look for an angle, what kind of function did we use?
Inverse.
Inverse functions. So all this is going to be is y equals sine inverse, that -1 means inverse of x, where now your y is the angle, and we are going to be given the function value. All right, so here's our parent function of sine, yes?
Yes, sir.
Okay, so if I'm trying to figure out the inverse function, what kind of line test do I need to use?
Horizontal.
Horizontal, right? But does it work right now?
No.
No, so what we need to do is wherever the horizontal line test does not work, I need to take that part of the function out. So if I start going to the right, it starts working, or it's working until I hit about right there, which is pi over 2. So I'm going to just take out the rest of that part of the function, such that the horizontal line test will work for that half of it. And then looking in the left direction, it works up until negative pi over 2. So I'm going to take out that part of my function such that now I can run a horizontal line anywhere through my graph, and it will produce an inverse function. So hopefully you have your sheet in front of you. We are going to be looking at sine function first. So if I take this and I find the inverse, now I am able to find the inverse because I have such that it will pass the horizontal line test anywhere on that function, correct? So if I flip the x and y values, notice now your y values are your old x values. They are your angles. And likewise, your x values are like -1, 1/2, 0, 1, right? Yeah. So your x and y's, they pretty much flipped where they were. So I have 0, 0. So I can put that point there. I know sine at pi over 6 is 1/2. And pi over 2, it is 1. It was just evaluating sine of whatever angle it is. Sine at pi over 6, if you look at your triangles, the opposite side is 1. The hypotenuse is 2. So sine of pi over 6 is 1/2. So I put it at 1/2. This is 1/2 right there. And at pi over 2, it is 1. Okay, so again, if you go from your triangle, sine of pi over 6, opposite over hypotenuse is 1 over 2, so those line up with each other. If you go sine of pi over 2, that's on your unit circle where your y value is 1. Okay, and it will do the same thing if you go in the other direction. Sine of negative pi over 6 will be -1/2, sine of negative pi over 2 will be -1. So it's just going to create the same sort of curve as your sine graph, but sideways. And I'm just making it relatable for you guys. The question was asked, why do we use the y instead of the x? Really, your x value, this is saying sine inverse of 1/2 equals pi over 6. But you guys understand it a little bit better right now going from the y value to the x value. Thank you. You'll forever be in my video. Yay! Oh my gosh. Alright, and don't forget, this goes from pi over 2 to negative pi over 2. Because of the restrictions we started with in the beginning, we can only have an inverse function exist between negative pi over 2 and pi over 2. So it is important for you to note that sine inverse of your function value only exists in, well, between negative pi over 2 and 2 pi over 2. You can only find angles in that quadrant. Quadrants. There's multiple. We're going to be doing the same thing with cosine. We're going to be figuring out where we can actually have an inverse function. So it looks like from this point to this point is where it would actually not repeat anything. And so for the horizontal line test, I can get rid of all that junk up in its trunk such that an inverse function would actually exist, and I can run a horizontal line test all throughout my function. So notice that is from 0 to pi. So if you want to, you can go ahead and make the restrictions say that cosine inverse of x only exists from 0 pi to pi. Those are the only places that we can have cosine inverse. You cannot see that. Let's make it so that you can see that. Yay, I can see it. Yay, I'm so happy. Oh, it's so pretty. Okay, so with your cosine inverse, smoky dokie, yalla chokey. So if we have 0, 1, we have a point over here. And then we have pi over 2, 0. Make sure you guys are focusing. I like it when you focus. You like it when you focus. Everybody likes it when you focus. Alright, so we have all of these points, yes?
Yes, sir.
Cosine, if you have an angle over 6, think about your triangles, or your unit circle, either one. Pi over 6, you have 1, root 3, 2. Pi over 3. Think about your pi over 3 angle. You know adjacent over hypotenuse will be 1 over 2. So at your angles over 3, that is where you'll have your halves. And then there's your function. That wasn't very good, but that's all right.
How do you know where it like curves?
Where it curves? You have to make it curve such that it hits all of your points. Like if you were to do all of these, this would be...
Like a straight line.
Okay, if you were to do all of these, this would be square root 3 over 2, which would be somewhere in here and would be somewhere in there. So you can see it curves. It's really close in, so it's hard to tell how much it curves. But I promise you it does curve, just like your cosine graph curves. All right, so we're going to be doing the same thing with finding tangent inverse. You're going from your tangent function and getting rid of anything that would make the horizontal line test not work. So looking in your right direction first, this is fine until it hits over there, and that's no bueno. Looking in your left direction, this is fine, then it hits over here, and that's no good. So the only thing that I have existing for tangent inverse is just like sine inverse. Tangent inverse of x only exists from negative pi over 2
How do you know those two are different?
to pi over 2. Okay, so in graphing tangent inverse, there's our tangent function. Sure you guys are focusing. There we go. Love you. You're on my booze and base. So you have 0, 0. It looks like we have tangent was pi over 4, 1. So at pi over 4, I have 1. And negative pi over 4, pi over 4, I have negative 1. And it's pretty much just going to be this picture on its side.
Does it matter?
It's like a gross pile.
Doesn't matter what.
Like on this side, the graph is like not going the same way that it is on the other side.
Okay, make sure you get this chart down. All this is stating is that the restrictions that we have already talked about. Sine inverse exists from negative pi over 2 to pi over 2. Tangent inverse also exists from negative pi over 2 to pi over 2. And then cosine inverse exists from 0 to pi. I'm just, yeah, that's just condensing all of the restrictions that we just wrote with all of our parent functions. Okay, so in evaluating these, it is going to give you the function value. This is your function value. All right, so if we are dealing with sine, and notice this is a positive function value, if sine inverse only exists between negative pi over 2 and pi over 2, it only exists in those two quadrants, where you have A, S, T, C. If it is negative in the quadrant down here, then it is not in this quadrant. So that means our angle, since our function value is positive, we will be in the first quadrant. For sine to be 1 over 2, you have opposite over hypotenuse. Kids think they're funny, they're not. But I'm not, I'm just an old crotchety man. So, if my function value is 1 over 2, I can look at my triangles. From pi over 6, my opposite is 1, my hypotenuse is 2. So hey, oh, that's all that I write, pi over 6. Happy day. Okay, with the next one down here, I know cosine inverse only exists between 0 and pi, so cosine inverse only exists in these two quadrants. If my function value is 0, the only place that my x value is 0 is straight up and straight down, but since the one straight down is not in my possible angles, I can only choose this one straight up, which that angle is pi over 2. Okay, with part C, I'm given the function value of -1. Remember that tangent inverse only exists in these two quadrants. That one is A, that one is C. So if you are in the first quadrant, that is where everything is positive, so I know I will not have a negative function value there for tangent. Tangent is negative down there. If you look at your triangles, to have a function value of 1, you must go from the pi over 4 angle such that opposite over adjacent will be 1 over 1. So we know we have pi over 4. It is in the fourth quadrant between negative pi over 2 and pi over 2, so I will just have the angle negative pi over 4. Alright, with this next one, cosine inverse is a little bit tricky. Make sure that you notice that this is negative. Cosine inverse, again, only exists in quadrant 1 and 2. If it is positive in quadrant 1, then I know I have to be in quadrant 2 with my angle. For adjacent over hypotenuse to be root 3 over 2. Since it's cosine, adjacent, hypotenuse has to go from your pi over 6 angle. So what that means is that this angle right there, that is pi over 6. Do not forget that your angles are measured from the positive x-axis around to it. If my reference angle is pi over 6, then it is 1/6 short of pi, which is the same thing as 6 over 6. So my angle would be 5 pi over 6. Okay, we're going to look at a little bit different type of a problem in this one. We are given secant of sine inverse of 4 over 5. This is going to be like your composition of functions. Remember when we had like f of g of x, and then we did g of x, and we took it and inserted it into our f of x function? Well, if I want to do that, I can do the inside part first, and this will give me some angle. Since I know that this is an inverse function, it'll give me an angle as an output. So if I draw a triangle, since trig is all dealing with triangles, and I go from theta, I know sine is opposite over hypotenuse. I can use the Pythagorean theorem to figure out that that side is 3. So really, this is just asking me what is secant of theta. Well, I know secant is related to cosine, so this is hypotenuse over adjacent. So I have 5 over 3, and there would be my solution. Okay, doing the same sort of thing here. So if I have tangent inverse of 3 over 4, again, I'm just going to be finding the angle. If I draw my triangle, I have the angle, opposite over adjacent, so opposite over adjacent. Again, this will be 5 by Pythagorean theorem. So really this is saying cosine of some angle. Well, cosine is adjacent over hypotenuse, so this one will be 4 over 5. All right, with ones like these, I'm actually going to be able to evaluate cosine of pi, because I know at pi, my x value is -1, so really this is saying sine inverse of -1. Well, don't forget that sine inverse is in only quadrants 1 and 4. So sine of -1 will sine the y value is -1 straight down. So this would be a y value of -2, or negative pi over 2. Whoops. Okay, here's our next one. I'm going to be doing the same thing. Evaluate tangent of 5 pi over 3. Well, I know that that is in the fourth quadrant, ASTC, so tangent will be a negative value, so this is going to be tangent inverse of some negative value. My reference angle is pi over 3, so from pi over 3, I have opposite is square root 3, I have adjacent is 1, so I can say that this is negative square root 3 over 1, which is just negative square root 3. Well, now I have to remember that tangent inverse only exists in quadrants 1 and 4. Since this is a negative function value, that means it will not be in quadrant 1. my angle has to exist in quadrant 4 since tangent is negative and it is only negative in the 4th quadrant here. For tangent to be opposite over adjacent to be square root 3 over 1, again that comes from your pi over 3 reference angle. So I know my reference angle is pi over 3, has to go in the negative direction around the unit circle, so my answer is negative pi over 3. Alright, last one of the day. Use an inverse trig, maybe we would say trig. Use an inverse trig function to write theta as a function of x. So I know I'm going to be using an inverse function. Well, this is my opposite side from my angle, and this is my adjacent side from my angle. So if I use tangent, I can say tangent theta equals opposite over adjacent. That's not an inverse function, but to write it as an inverse function, I would just say that the angle equals tangent inverse of my function value, which is x over 4. And there would be my inverse function, theta as a function of x. Hopefully this video has been helpful for you guys. Make sure you ask lots of questions in class. Write your questions off to the side if you want to remember your questions later. Get some good work done. Love you guys, and I will see you soon. Bye-bye!